Hello, my dear students. I welcome you once again to our online lecture series. In this lecture, today I'll be presenting on the goodness of faith. Right, so let's dive into the presentation.
Welcome to this video on goodness of fit, a key aspect of evaluating statistical models. I'm Dr. Chingshubham Manimohan Singh, and I'll be guiding you through this topic. Goodness of fit measures how well a statistical model matches observed data. It is essential for determining if a model's assumptions hold true, enabling refinement for more accurate predictions. Goodness of fit is critical for model reliability. It helps assess if a model adequately represents your data, supports hypothesis testing, and allows you to test for normality of residuals and compare distributions. In practice, goodness of fit tests are used for many purposes. These include testing if samples come from the same distribution, verifying independence assumptions, and assessing if residuals are normally distributed. The chi-square test compares observed and expected frequencies for categorical data. It assesses independence between variables, and a significant statistic indicates rejecting the independence assumption. The Kolmogorov-Smirnov test is a non-parametric test. It compares cumulative distribution functions and is useful for continuous or discrete data, especially with larger sample sizes. The Shapiro-Wilk test assesses normality by comparing a sample distribution with a normal distribution. It is particularly effective for small samples and provides reliable results with limited data. The Anderson-Darling test compares a sample's cumulative distribution function with a reference distribution. It is especially sensitive to deviations in the tails and useful when tail behavior is critical to the analysis. Other tests include the Lilliefors test for small samples, the Kremer-von Mises test, and the Jarque-Berra test for skewness and kurtosis. The Hosmer-Lemichaud test is used in logistic regression to assess model fit. Choosing the right test involves considering your data type, sample size, and research question. Different tests have different strengths and sensitivities, and careful selection ensures valid and meaningful results. In healthcare, goodness of fit is used to assess models predicting disease prevalence and survival rates. It is also important for evaluating treatment effectiveness and ensuring clinical decision support models are reliable. In finance, goodness of fit evaluates the accuracy of stock price forecasting and credit risk models. An example is applying the Anderson-Darling test to stock return distributions for informed investment decisions. Goodness of fit in marketing involves examining models for predicting consumer behavior and assessing customer churn. It helps validate models that accurately represent market patterns, improving targeting and resource allocation. For environmental studies, these tests assess models predicting pollution levels and climate patterns. For instance, the Kolmogorov-Smirnov test can be used for rainfall pattern predictions to support environmental policy decisions. The test statistic measures the discrepancy between observed data and the model. The p-value assesses its significance. A p-value below a threshold, typically 0.05, indicates poor model fit. The null hypothesis, H0, assumes no significant difference between expected and observed data. The alternative hypothesis, H1, suggests a significant difference exists. Reject H0 if the p-value is below the threshold. Interpret results by examining the test statistic and p-value together, considering your research context. A non-significant result does not imply a perfect model, and a significant result indicates room for improvement. Best practices include selecting the right test and verifying assumptions. Report both the test statistic and p-value. Use results to refine models and document your methodology clearly. Goodness of fit is essential for model evaluation. Tests like chi-square and Kolmogorov-Smirnov are widely used. Proper interpretation of results guides model decisions across various application fields. Consider how you will apply goodness of fit testing in your work and which tests are most appropriate for your data. Continue to learn about model validation and statistical inference techniques. Thank you for your time and participation in this exploration of statistical rigor.